Good morning. Let's keep going, and I'm going to go ahead and bring up the calculator so we can talk about what we're doing. All right, I'm in 10.3, which is t-test. And the big way to know that it's a t-test is if you do not have a population standard deviation. So let's read this question and get out what we need from it. The Director of Research and Development is testing a new drug. She wants to know if there is evidence at the 0.5 level that the drug stays in the system for more than 357 minutes. For a sample of 19 patients, the mean time the drug stays in the system was 364 minutes with a standard deviation of 25. Assume the population distribution is approximately normal. All right, so let's go back up here and see what we have. We have a 0.5 level of significance. We know it wants to stay in their system more than 357 minutes. It's a sample of 19 patients, which is N. And the mean time for the sample is 364 minutes and a sample standard deviation of 25. So now that we have all that information, let's go get our hypotheses. Again, I'm talking about means, so I'm going to use my mu symbol, and of course, Hawks will give this to you, so I'm going over here and getting the mu. Okay, this one I'm going to start with my alternative because it says more than 357. So because that's the population mean, I'm going to put the mean is greater than 357. So I'm going to put the mathematical opposite for the null, which is going to be less than or equal to 357. Okay? All right, the next thing I need to do is I need to bring up my calculator and I need to put it in there. So for this one, I'm going to go to second bars. Excuse me. No, I'm not. I'm going to go to stat, go over to test. Sorry about that. And go to number 2, t-test. Again, we know it's a t-test because nowhere in here it shows that there's a population standard deviation. Scroll over to stats and hit enter. And look, it changes your screen. So the first thing it asks for is the population mean, which is the mean in your... Oops, sorry about that. My calculator did something weird. So go back down to here, and then you hit OK. Hit stats again, and then I'm going to go, okay, so this is 357, because that's the population mean. My sample mean is 364. Okay, this is where it changes from the last one we saw. SX is your sample standard deviation, and it for this one is 25. Your N is 19, and we know this is a greater than scenario, which is the one on the N, so I click over that. So all I've done is enter my information in my calculator. I hit calculate. All right, so what do I get? I get my T is 1.2204. So let's go down here. So T equals 1. Let me see where I'm getting this from again. 1.220. Okay. I know this is a one-tailed test. I know it's a one-tailed test because of this symbol right here in the alternative hypothesis. That shows me it's a greater than series. All right. To find my decision rule, you're going to go to the table. If you have the book, it's table C. It's the critical values of T. And I knew this is a one-tailed test, and I knew my level of significance was 0.05. The other thing I need to know is my degrees of freedom, which is N minus 1. So if I go back up here, I know that my sample size is 19, but I subtract 1 from it to get N minus 1. So I go down here, and I know my value for that would be 1.734 because it's a one-tailed test, it's 0.05 level, and degrees of freedom equals N minus 1 equals 18. Okay. So you don't even have to use the T value to see if you're going to reject or keep the null. Remember the people, let me put this, eat fish, from the river Nile. All right, so let's see what our p-value was in our calculator. If I go back, my p-value was 0.119, and is that less than or equal to, let me put that back in, 0.05. And it's not. This is not a true statement. So because it's not a true statement, I fail to reject the null. All right, so let's go up here and look and see what that means then. So if I fail to reject the null, it means that the mean is greater than or equal to, excuse me, the mean is less than or equal to 357. So I'm going to put that right here. So that is my true statement. Okay. Okay. All right, so let's keep going to another example. Here's another way to look at these. The director of research and development is testing a new drug. She wants to know if there's evidence at the 0.025 level that the drug stays in the system for less than 301 minutes. For a sample of 13 patients, the average time the drug stays in the system was 294 minutes with a standard deviation of 25. Assume the population distribution is normal. Okay, this one is basically the same like we did last time. So, all right, the only thing that's different on this one is this is a less than. So we do that, less than, and this one, our population mean is 301. So I'm going to put the mathematical opposite in the null. The mean is greater than or equal to 301. All right, so now put everything in the calculator. So on stats, test over to t-test. Okay, so population mean is 301. Sample mean is 294. Okay, my sample standard deviation is the same, and my n is 13. What changes is, again, is these hypotheses. So I go pick this last one, which is less than, and I hit calculate. So here I go. My t-test, t equals negative 1. Let's go back and look at it. I think it's 0.9. Yeah, 1.009. So I'm just going to round this up to 0.10. Okay. I know it's a one-tailed test. How do I know it's a one-tailed test? Because I'm comparing this symbol up here, the less than, with the one-tailed test. Okay, my decision rule again, I need my one-tailed test, comma, I need my level of significance, which is 0.025, and I need my degrees of freedom. And in this case, it was 13 was my sample size, so I need to do 13 minus 1 equals 12. Okay, so I go back and look in my book. I go area one-tailed, 0.25, and I go down to 12, and I get 2.1, excuse me, let me go find it, 2.179. But because this is a left-tailed test, I have to make it a negative. If you get confused, look at the chart in the book. It shows you left-tailed, right-tailed, and two-tailed scenarios. So that's how I get my t-test. Okay, so let's go down and let's do the conclusion. All right, so I'm going to compare my p-value. My p-value is 0.1663. So 0.1663, is that less than, let me put in the symbol, less than or equal to 0.025? And that is not a true statement. So again, I'm going to fail to reject the null hypothesis, which means that if I go up here and look at it, oops, I went too far. This one is correct. The mean time is greater than or equal to 301. Okay, so I'm going to put this right here. All right. So that is a true statement. I hope this helped. Let me know if you have more questions.